to the HPC Singularity tutorial. We're right now recording, so. We're just going to take a few more minutes to make sure everybody can log into the VMs and get up to speed. Has everybody logged in or signed in rather to the sign-in sheet? Just a recorded edit. So we're going to start off today talking a little bit about the larger ecosystem in which Singularity sits, and so I guess that's a good way to introduce today's class. That'll be chapter 3, and so we're going to be talking about the web services that support Singularity, and you know, different places you can go to get help and so on and so forth. Okay, so yesterday we ended by talking a little bit about how to build Singularity containers. And we're going to get back to that later on today, and we're going to talk a little bit more about some advanced topics. But I want to talk a little bit more about where to find pre-built containers and how to manage them and how to actually share the containers that you've built using the same ecosystem. So the two places I'm going to talk about today are the Singularity Container Services, which I've mentioned several times before, but we haven't really visited yet and talked about yet, and then also Docker Hub. And I'm just going to give you a few pointers to help you out with those. So we've already visited a little bit. We're talking about Singularity Container Services. Obviously, I haven't searched for them. Just go to Sylabs.io, and then if you go over here to Cloud Login, that'll bring you to the Container Services. The Singularity Container Services are composed of 3 different pieces. They're composed of a library, a remote builder, and a key store. Each of those are useful for 3 different things. So with the library, you can search the library for you know, pre-built containers, or you can share containers that you've built there as well. With the remote builder, you can use that to build your containers. I'm going to show you how to do that in a little bit. And with the key store, so yesterday we ended talking a little bit about security, and we talked about how you want to be careful about running containers, especially as root, because they could contain malicious code, and you don't necessarily know that. The key store gives you a way to trust the containers that you're running. So we're going to talk about this in a little bit more detail later, but the basic idea is that containers can now be signed cryptographically. You can generate a key through Singularity. You can sign your containers. You can push the public cryptographic material up to the key store, and then others, when they download your container, they can verify that your container is signed and is a bit-for-bit reproduction of the one that you've produced by checking that key and using that public key material. And that doesn't complete the circle of trust. The circle of trust is completed once either you post your fingerprint that you actually signed that key with, or somebody contacts you and gets that fingerprint. But once you've got that fingerprint, you can verify that that key belongs to that person. You can also verify that key was used to sign that container. That way you can know that that container at least was built by a trusted entity. So we'll talk more about that a little bit later. Okay. And then I want to go over to Docker Hub too and give you a little bit of an idea of what that looks like. So once again, this is my sign in. Let me just sign out. If you're not signed into Docker Hub, you'll see something that looks like this. And then you can just search. You can say, yesterday we searched for SAM tools. 448 containers that have something to do with SAM tools already up on Docker Hub. So if that's something you were interested in, you can see how many people have downloaded them. And you can grab one of those containers. Okay, so let's talk a little bit. Yesterday, I talked about how to build containers from Singularity Hub and also the Singularity Library and also from Docker Hub. I did so in a very non-reproducible way. I just said, let's just build a Debian container. And when I did so, we grabbed the default Debian container that is up on either the library or in Singularity Hub. Let's talk a little bit more about that. So both on the Singularity Library and also on Docker Hub, there's a concept of tags. And if you're used to working with Git and GitHub, you might already kind of like have an idea what tags are and what they're useful for. In Git and in GitHub, well, in Git, there's a concept of a tag. You can say, okay, I'm working on some code and it's evolving and I've got all these different changes. I want to tag this particular change as being important. And in practice, what people usually do is they use tags to indicate this is a release. This is, we've reached some milestone of development here, and this tag is an important version of the code. It's a release. We do the same thing with containers. So a tag is there to indicate, something about the container. This is, this is an important container. There is a special tag. So for instance, I'm not going to actually do it, but here are some examples. If you wanted to pull a particular version of Debian, the syntax for that would be that you would give it that :9 there at the end. And that would indicate this is the tag that I want. Or if you were going to do that in a definition file, once again, that :9, that's the syntax to indicate a specific tag. Now, if you don't indicate a tag, this is where things get a little tricky. If you don't indicate a tag, you're still pulling a tag. And the tag that you're pulling is latest. Latest is a special tag. It's special in the sense that on Docker Hub, if you upload a container there, you build a container there, and you don't indicate any kind of tag, Docker Hub automatically assigns the latest tag to that container. I think with the Singularity Library, you might actually have to specify. I think we've gone through several iterations. You might actually have to specify that the tag is the latest. But in any case, when you're pulling, if you don't specify anything, you're getting latest. And you can run into problems both on Docker Hub and also on Singularity Library where you see a container, you know it's there, you try to pull it, and it's giving you some lame error about how it can't get the latest container, but you can see it right there online. And that's because that container does not have the tag latest. So if you're just by default trying to pull it and it's supplying latest, you can run it. It's not smart enough to say, oh, well, this container doesn't have the tag latest. I don't know. It's just going to say, I don't know which one you want. I'm going to leave it up to you, and here's an error. That's something to be aware of. Another thing is that, so one of the things that people like to use Singularity and containers for in general is reproducibility. And so we should talk a little bit about best practices surrounding that. So let me get into that, and I'll start off by talking about tags and hashes. Now a tag is a little bit better than just pulling just the image and just give me latest and that's it. But it's still not great because unfortunately developers can replace tags, and they do replace tags sometimes. I had one instance in which I was pulling this container using this particular tag of this container. I came back to that container like a month or so later and tried to pull the same one, and spend a day being very, very confused trying to figure things out because they had removed a lot of the programs that were previously in that exact tag, and it was a totally different container. So that can happen. So if you want to make sure you're pulling the exact same container and be a little bit more reproducible in your definition file, the way that you do that is use a hash. So, both with Docker and also with Singularity, there's a way to take a hash of the container. That way it differs because the underlying file type differs. But a specific container can be referred to by a specific hash, and you can find those hashes on Docker Hub. See if I can find one. There we go. And the hash, actually, I believe, here we go. It'll say SHA-256. So that might be a little small for you guys to read in the back. Probably you don't need to read that anyway to know it's a hash. But, if you copy and paste that, then you're going to get the hash. The container library, see if I can find it there. Oops. Yeah, and the hash is a little bit easier to find on the container library. It's a little bit more front and center. And actually, a little bit, there are things that I like about the Docker Hub layout and things I like about the container library layout. In general, I think it's a little harder to find images that you're looking for on the container library, but things like this are a little bit easier. So you can actually just show the pull command, and it's going to give you even the pull command to pull by the hash, so you get that exact same container in each case. One thing to note in the tutorial here, and I've kind of highlighted it, for historic reasons, the syntax to pull from a particular hash differs between the container library and between Docker Hub. So you'll notice this little @ here, and then this is a dot instead of a colon. Sorry, this is a dot instead of a colon. I've talked to the developers about that. I think that that's like something we can probably change, but that's a kind of a spandrel. Yeah. No. Well, for one thing, I have no idea if these are the same Debian containers. Like they might not even be the same version. But for another thing, even if they're the same container, they're not really the same container, right? Because a Singularity container is a CIF file, and a Docker container is a bunch of tarballs connected by a manifest. So even if you took the hashes of those, they wouldn't be the same. Good question, though. Okay, and then I want to talk a little bit about defaults. So yesterday, I did a lot of this, Singularity pull library Debian. When you do that, Singularity makes a lot of assumptions. You're not actually supplying Singularity all the information that it needs to get the container. On the Singularity container services, the library is actually organized like this. There's a user or an entity. There's a collection. Within that collection, there's a container, and then there's a tag. And so if you just say, I just want the Debian container, then it's going to say, okay, well, the user, we named library, just to be confusing, but that's the kind of Sylabs default user. Default underneath of library is the standard collection, and then latest is always going to be the tag that's supplied for you if you don't supply a tag. So this expands out underneath the hood to that. And you might need to know that. Because, for instance, if you tried to pull the container that we were playing with yesterday a lot, by that shorthand, you're not going to get anything except for error. And that's because that's a container that I built in my personal capacity. It's not like a Sylabs, official container or anything. So you would have to supply my username, Godlove DC. The collection is funny, and then that particular container in order to get that one. And then if you did that, of course, you get latest. So just some stuff to be aware of. This can be confusing as you see online instructions, and you see sometimes there's short URLs and some URIs, and sometimes there's long ones, and you don't know what's going on. That's because Singularity is supplying some default information. Even if you pull from, okay, so if you're going to pull from the Singularity Container Library, there's really only one of those, right? It's set up in such a way that there can be more than one of those, but if it's set up in such a way that your organization might host its own Singularity Container Services. If that's the case, you will configure Singularity to point to an entirely different remote. And that, you just won't have to worry about that. You'll do that configuration once, and then it'll pull from something different. The Docker Hub's a little different. Docker Hub is just one of many different registries. So you might actually want to pull from something like Quay.io or Nvidia's registry or something from AWS or something like that. If you wanted to do that, you need to know that by default, Singularity, if you use the Docker URI, it's going to fill in this little bit here. It's going to fill in this address, which just happens to be Docker Hub. So if you wanted to pull from a different one, you would have to supply this long version, and you would have to change this to something like Quay.io or whatever the address is for. Okay, so that's a little bit more in depth about how to pull containers, how to control what containers you're getting, how to be a little bit more reproducible. I mentioned I was going to talk a little bit more about reproducibility, and now is a good time to do it. So I've told you how to be a little bit more reproducible in your definition file. Okay, I'm going to put some scare quotes around that though, or some parentheses or whatever. So if you are using a definition file, and if that's your strategy for reproducibility, you're already sunk. Definition files are not reproducible. And this is something I think that the container community is not, is sort of grappling with and is not really necessarily completely on board with. If you don't believe me, or if you're confused about why that is or something, then maybe you should create a definition file to build TensorFlow and just leave it on the shelf, make it work, and then leave it on the shelf for a month, and then come back and try to make it work again. It won't work. And that's because the internet is constantly changing. And those instructions that allowed you to build TensorFlow last month are going to, TensorFlow is something there's a lot of churn, there's a lot of development on it, it's constantly moving. I, one night, was building this container, starting with the TensorFlow container and then pouring more stuff into it. And I'm developing this definition file, and I'm doing that process that you and I talked about yesterday, where you are iteratively building the container over and over again as you kind of mess around with it. And in the middle of doing that, it broke, and I couldn't get it fixed. I didn't have any idea why. And it turned out that the tag that I was building from had disappeared from Docker Hub while I was in that development process. So if your definition file is your strategy for reproducibility, then you're in bad shape. If you want reproducibility, you actually have to save the container. You need to archive the container. You need to hold on to it. You need to make sure that that container, you can always get back to it, because that's your strategy for reproducibility. All right. And now we're going to talk a little bit more about security. Okay. Security is a really big topic in general. Also within the container world, security is a very big topic. it's big and it's confusing. And one of the reasons it's confusing is because there's multiple different facets to it. There is the security of the container runtime itself, right? And there's that whole, and there's lots of issues and topics and things associated with that. And then there's the security of the containers that you are running within that runtime. And then those two things interact, but they're kind of like two different, threads. So I'm not going to get all into that. Like, I could probably teach a course just on that. But I want to talk about a few topics, a few things on that. So number one, there are a lot of vulnerabilities that would normally be vulnerabilities inside of containers are vulnerabilities when you run them with something like Docker or Podman or some other, something with elevated privileges. They might not be vulnerabilities when you run them inside of Singularity. And the reason for that is because lots of these containers rely on the fact that the container environment allows you to elevate your privileges in order to be vulnerabilities. So because of that, you can't just take like some container and turn a vulnerability scanner loose on it and find, oh, this is an old version of CentOS and it's got all these vulnerabilities in it, and then say, okay, well, this container is vulnerable now to all these, because it depends on how you run it. It might not be vulnerable to any of those vulnerabilities. So that's something to be aware of. Like if you go to Quay.io, for instance, they've got an automated security scanner that runs on all the containers, and you'll see like, oh, this container's got 275 vulnerabilities in big red. And, well, it might, but a lot of those might be rendered moot depending on how you're running the container. The flip side is that if you run that container as root, something like Singularity might actually be more vulnerable than something like Docker. The reason for that is because Docker assumes that you're going to run as root anyway, and so those developers are trying to put things in place to protect you if you run as root. Whereas Singularity is like, you run as root, that's on you. And that's a silly thing to do, and that's outside of the use case. So this is, like I said, it gets very complicated, and what one development team counts as a CVE might not be counted by another development team because the product is different and because the use case is different and so on. But it is important to note that you are taking a risk when you run containers as root, right? Because you're downloading somebody's code from the internet. There's a lot of code inside of a container. A lot of it's compiled. You're not going to audit it yourself, and you're just going to trust and run that. It's worth noting, too, that even if you run as non-root your container, they can do a lot of damage to your system. They can do a lot of mischief. And this is something that a lot of times we don't really think about and we don't really talk about. I've got a container on Singularity Hub that when you download and run it, it copies files to your home directory. And it's, it's supposed to be a nice thing to do because it's going to give you some things that you can run out of your home directory. And that's cool. But if I can do that, if I can copy files from a container to your home directory, just normally, just think what else I could do. And so you have to be careful about that stuff. So you should try to trust the containers that you're running. This is something that I don't think that the community is really catching on to yet. I think that it's been kind of slow going to get this idea moving. But there are, Docker's kind of catching on to it, and they are putting some things in place to allow you to verify and trust the containers that you're running. Singularity is moving in a little bit of a different direction, but has also got this in mind. And I think that as the community starts to use this, you're going to see more and more signed or official certified containers, all those kinds of things. And we're going to start moving more in the direction of using those versus using random containers from the wild. So let's talk about this a little bit. So I give you some, there are some pointers here for what how you should run containers. One thing to be aware of when you're building your containers, a lot of times you're starting from a different container. So you might say, okay, well, I've built this container. This is my container. I built it, so I know everything's cool. All right, but what was that base that you started from? Did you start your container from an untrusted base? Because then it still might have stuff in it that you didn't put in there and might be, worrisome. What we did yesterday, we started off building directly from the operating system mirrors. That's not completely foolproof, but that's pretty good, right? If the operating systems have been hacked and somebody's been able to insert something into those mirrors that's malicious, then we have a lot bigger problems than just containers, right? We have operating systems that have malicious software in them, which can happen, but it's a much better way to build your containers probably. If you're going to build them from Docker Hub, there are some things you can do. So Docker has, so their basic model, Docker Hub's at a very high level, is you guys trust us, trust our company, trust Docker. And we're going to have official images, and we're going to have certified images. And when you're downloading those, you're putting your trust in us as a company that we've done our due diligence. That's kind of their model. And so the official images are ones that they've actually worked together with companies like Canonical, for instance, who makes Ubuntu, or Nvidia, who makes a lot of containers that are up on Docker Hub, or so on and so forth. They've worked together with these companies. They've reviewed the process of building the container, and they're saying, and actually in some cases, I think that the Docker team is actually working on building the containers themselves too. So those are like official, we've built them, you can trust these. Certified images, if I understand correctly, are a little bit of a lower bar. It's a little bit more like, if you as a developer are able to run these security scans on your container and then verify that you've done these best practices, then we will certify this image. And then once we've certified it, then you can download a certified image. As general, as is kind of like the case usually with Singularity, Singularity has actually put this in the hands of the users. So whereas Docker is saying, trust us as the company, we'll certify and make these images official, Singularity is saying, trust the entity that built your image. And it's both a plus and it's a minus. It's like it goes kind of both ways. So we're going to see how to do this a little bit later, maybe here, yeah. As I said a little bit earlier, when you build an image, within Singularity also you can generate keys. You can generate and manage keys within Singularity. You don't have to do it within Singularity, but you can manage keys there. Then you can cryptographically sign those images. And what that's going to do is it's going to add a signature to the image itself, and that signature is going to need an external piece of information, the public PGP key that was used to sign it, in order to verify. And once it does that, cryptographically, it's going to ensure that that image is a bit-for-bit reproduction of the image that the original author created. And so that's how that works. Now, there's one more piece, though. Anybody can sign an image, right? So if you download an image from Singularity, and it's not like Docker where they've certified that these are good folks who are building good images and they're not including malicious software, right? Anybody can sign an image. So you could download some random image from the Singularity library and check it out. Oh, it's signed. It's signed by this evil person who's trying to hack my computer. Cool. And then you could assume that it's okay and run it, and it's not. So there's that additional step where you actually should be trying to get, and I don't know if this has been, if people have figured this out yet, but you should be trying to get the fingerprint of the author, either from their website or emailing them, or they write it down on a sticky note or something and give it to you. But you should get that fingerprint to ensure that that is the the correct signature on the image. And once, I think that, we need to start having companies, for instance, start to do this on Singularity, the Singularity library. And once we start, doing that, we're going to start to see some critical mass and things moving in that direction. Okay, so let me, yeah, the next thing I'm going to do is I'm going to go through a demo of using essentially all the Singularity container services. I'm going to build a container. I'm going to sign it. I'm going to push the key up to the public key store. I'm going to push the container up there. And that way, anybody who downloads that container can then download it and then can check the signature. Let's see what this workflow looks like. Before I launch into that, this is going to be a little bit more hands-on. First off, you can follow along with this. You don't have to, but you can follow along with this as well. This is going to, as I go through this, one of the things I'm going to do is I'm going to log in to Singularity Container Services. They're going to authenticate, in my case, against Google. You can also authenticate with like Facebook and GitHub and a bunch of others, but you have to create an account. So not everybody might want to do that. If you don't want to, fine. If you do want to, go for it. And then I guess maybe I should pause at this point before I jump in and roll my sleeves up. Does anybody have any questions? Yes, I'll try to do that. All right. Oh, yep. Maybe somewhere down the line. Actually, right now, you're not going to get into trouble. And the reason for that is kind of like the way the Singularity works. Once again, so if let's say you're on Beowulf and you start downloading containers on Beowulf, you might do things that are going to hurt yourself. You might accidentally delete a bunch of your own data or something like that. You're probably not going to get into too much trouble as far as like hurting the system. So these are things, I mean, at some point, so there's no like, well, there may or may not be automated scanning for things like you downloading random shell scripts from the internet and running them in your space on Beowulf, right? You could do that if you wanted to, probably. You know, if you kept doing it, you'd probably get into trouble. Likely, the only person you would hurt is yourself if you did that, if you hurt anybody.
Possibly other people that you share a group with,
right,
or share data, so obviously you should show due diligence. But
yes,
it's you and your colleagues who hurt most.
Yeah, so for instance, if somebody, and a lot of times too, this is another important thing to know, a lot of times these kinds of the things that actually end up hurting you are not because people have malicious intent. They're because people just do things that are silly. So you might have a random RM, RF star in your script, and that script might not check where it's at, and it might accidentally be in the root directory when it runs that. And then you're not going to delete a bunch of stuff from the system that the staff cares about that's important to run the system, but if you share a data directory with a bunch of colleagues, you might delete all that stuff. So yeah, this is the kind of thing that Andy makes a good point. It can do a lot of damage if you're not careful.
There was a question from the remote audience about how do you verify the key?
Oh, how do you verify the key? Yeah, so I'm going to go through that in a moment.
Great.
Okay, so the first thing to do is actually to log in. In order to use the Singularity Container Services, you essentially have to log in online, and then you create a token online, and then you copy that token locally. And then once you've got that token copied locally, then your SSH session, your VM, whatever it is, it knows it's authenticated, it knows who you are, and it can talk to the Singularity Container Services. So, and the way to do that is Singularity remote login, and then it's this Sylabs cloud. I myself can never remember that. So if you do 30, command's not found. Anybody else getting this? Oh, you know what? I might be using the wrong VM. All right, everybody. I'm not using the same VM that I created yesterday. That's better. Okay, so I can never remember the actual way to log in. So if you do like Singularity, remote, login, help, or the previous thing that I did will be equivalent to that. It's going to give you help for the remote login command, and it's going to give you this example, which is exactly what you need. So that's a quick little shortcut to. The reason that we have this Sylabs Cloud is because, as I alluded to before, you might be logging into, in the future, maybe Singularity Container Services, which are hosted by your organization, or which are hosted by, I don't know, maybe Red Hat, or some other place. So this is going to log you into the one that is run by Sylabs. Okay, now it's going to ask you to generate an API key. And I'm going to do that, and I'm actually going to, for just a moment, hopefully I can get back to this, turn the screen off and stop sharing. I'm just going to share the application. Okay. Now you should just see my terminal. Is that correct?
Yes.
What you're going to do is you're going to navigate over to Sylabs. So that when you enter that command, it gave you basically a little URL. Just follow that URL. And that's going to take you to Sylabs Cloud. You're going to sign in. And that URL is going to take you to a place where it says generate token, or my tokens. There's a little text box. Enter the name or something about the token that you'd like to generate. Create your new access token. And you can copy that to the clipboard and paste that back in to where it says the API key. Now it's a little tricky. The API key, when you paste, it's not going to do anything. It's just like a password. So that's tripped me up before. If you do it once and it doesn't work, just hit up, get the same command, do it again. You don't have to generate a new token. That same API key will work the second time. So that's basically how you generate the token and log in. Everything again. And the reason I didn't share that, just so everybody is kind of on the same page, that token I will expire at the end of class, but it'll be active while I'm doing this stuff. If somebody on WebEx did a screen cap and then manually entered every single little thing there, then they could have gotten into my session. Okay. If you're having trouble doing that, raise your hand. I do, but it doesn't have Singularity installed with it yet. Yeah. This is the one I was just using a second ago, which is blank. So now that you're signed in, if you are signed in, or now that I'm signed in, if you're just watching, you can do things like Singularity search. And I'm going to search for, I know I've got a container called wine. If you search for a container, it's going to try to find users with that name, collections with that name, and containers with that name. And it's going to find that I've got a container based on wine, in this case. And it's even going to give you the URI for downloading. So you can just copy and paste that into a Singularity pull command or into a definition file or something, and then you can start from that container. Going to search for funny, just to show you how finding a collection works. And let me search for Alpine. We're going to see lots and lots of containers. So Alpine is a very, very popular base container. And the reason for that is it's only a few megs. It's a very, very minimal version of Linux that if you're really, interested in making your container small. That just tells us that we're logged in, we're ready to go. And it gives us also a way to search for containers. Okay, now's a good time, I think.
So first of all, can we run a container inside a container like you can run a Docker daemon inside the Docker privilege mode?
I've never tried that. There's like, if you search on the Google group, there's, that's a hot topic. Actually, or kind of was a hot topic when Singularity first started. I think it's completely possible if you run as root. So, yeah.
With all the caveats? With all the caveats, of
yeah.
course, that go with running Singularity as root.
Sure. Oh, is it just not echoing to the screen? Yeah. I should stand behind the podium. So the question is that the API key, when you enter text, it just looks like it's frozen. And that's the same as the password. So it just does, it should still enter. It just, there's people sitting behind you and it doesn't want them to be able to copy your key.
And the second question, how to set when the token expires? Is there a way to manually do that?
That's a good question. I don't know that. I don't know the answer to that. So the question is, how do you set when the token expires? You can manually expire the token. So let me go. If you go back over to access tokens, now all this information is just like, this is stuff that's okay to show publicly. You can revoke the tokens yourself if you want. They are expired after a month, 2 months, something like that. I don't know what the time frame is. I don't know if you can change that time frame yourself, though, or if that's just something that's managed by Sylabs. But yeah, if you wanted to expire it, you could totally just expire it manually here. I'd have to search through the command line interface, too. There might be a way to expire your tokens through the CLI. There probably is, but I'm not aware of it.
Thank you.
Yep. Okay, so we're signed in. Now I'm going to go ahead and build a container. And so to do this, once again, I'm going to do this from a def file. I'm just going to copy this silly little definition file here. And this is going to build an Alpine container. Actually, you know what? I'm just going to use, yeah, I'll just use this. So this is going to build a very, very small container. that LOL cow directory just to keep things clean. This is going to build a very, very minimal container. This section is just a dummy section. It's just going to echo something saying it's installing stuff. It's not. This is just going to give us the latest container. This is for demonstration purposes. Now, what I had told you to do before is yesterday. It is something like sudo singularity build alpine.sif from the alpine.dev container. I want to use the remote builder to build this, demonstrating how to use the Singularity container services. So the way you do that, notice I just removed sudo. You don't have to do this as root, which is the main draw. You just have to add that little remote command. And now that you're logged in, under the hood, what this is actually going to do is it's going to reach out, say, hey, Singularity container services, I've got this definition file. Build this for me. They're going to say, okay, they're going to build it, and then they're going to copy it right back down to you. And this is what it looks like. It looks like it's all building locally. And now if I look at alpine.sif that I just built. So pretty cool, huh? And you can actually do this on Beowulf. So you can build your containers on Beowulf through the Singularity container services. What I do is generate a token and authenticate.
Entirely over HTTP, or does it need direct access?
It's all HTTP, so you can do it on a compute node. I actually do it regularly on compute nodes. There are some caveats. Number one, the container services are in beta, which means that you probably shouldn't use them for production. Like, corporations would not trust the container services as they are now because they're in beta, and they might be subject to change. Number two, Sylabs is paying for cloud instances for this to work, and so they don't want people using all their cloud instances to mine Bitcoin all the time or do something like that. So they set limits on the size of the container you can build, the time that it takes for you to build the container, and stuff like that. So you can run into caveats. There are other things too. In the definition file, we didn't talk about it, but there is a files section. I briefly mentioned it, and it will allow you to copy files from your host system into your container. That's not going to work very well if you use the remote command, because that's, you're going to be using this virtual machine up in the cloud that doesn't have those same files on it. So in that case, you would have to push those files somewhere where you can use wget or something to download them, or maybe put them in a GitHub repo or something along those lines. Or just, put them in a directory and bind mount them into the container at runtime. We'll talk more about how to do that later. Okay, so now I've got this container. Cool. I built it using the remote builder. I want to share this with everybody. I want you to be able to download this container, and I want you to be able to verify that it was me who created it. So the first thing I want to do is sign it. In order to sign the container, I need to either have a key already, or I need to generate a key. In my opinion, Singularity almost makes it a little too easy to generate new keys. What you really want to do is you want to generate a key and then hold on to that key and keep that key safe and use it to sign your containers. Because down the road, when people start catching on that there's this thing called security that they should worry about, and they want to download your containers, they're going to want to know what your fingerprint is. And you don't want to be like, well, I have this fingerprint for this container and that one for this one, and I've lost all my keys, and I can't generate another one with the same fingerprint anymore. And so here's this list of 20 million different fingerprints that might belong to me. You want to have this one fingerprint, or maybe a set of fingerprints that reliably belong to you in the containers that you create. In any case, to create a new key, Singularity key new pair is the way to do that. For your name, this can be anything, but you know, if you want the people who download your container to know it's you, you probably want to enter your key as you. Your email address can't be anything. That's got to be the email address that you used to authenticate into the Sylabs cloud. And it's going to check and make sure that those add up. So I have to enter a comment, that's optional. Passphrase, that's also optional, but if you don't, Singularity is going to yell at you. Then it's going to ask you, you want to push this key to the key store. So, you know, if you are familiar with like your SSH keys or whatever, you know there's like two different parts to your key, right? There's like the public part and then there's the private part. What this is going to do is it's going to push the public part up to the key store so that other people can use it to verify that your containers are signed appropriately. Yeah. It's going to generate that key for me. Cool. Okay. No. You do, because you're going to use it whenever you sign a container. That would prevent somebody else, you know, say somebody steals your key, that gives you some time to let people know that your key has been stolen, revoke it, and do things like that before it doesn't like protect your key permanently because somebody's going to crack your passphrase eventually, but it gives you some time. Okay, and so now, so yeah, you should keep this key, obviously keep this key safe. I want to sign this Alpine container that I just created, so you guys know that this is my Alpine container that I created. Here's where it's important to remember your passphrase. Okay. Now that container had what we called a signature block added onto it, so it's actually got some more metadata that's been tacked onto that container. Now wherever that container goes, it takes with it this information that it is signed and that it can be verified. This is something that's kind of cool about the Sylabs approach, is that it doesn't really depend on the Singularity container services, right? This whole workflow can operate independently of there being a key store, of there being any of that stuff. I can just email somebody some public key material, or, you know, give it to them some other way. And the cool thing too is, if the library gets hacked and somebody comes in and replaces all these containers with different containers that have malicious software in them, doesn't matter. Because those containers, by the rules of cryptography, are going to have different bits in them. And so, and because the container itself has the signature block as part of the container, you can't just, you know, download a different container and it's you know, it's going to have a different signature block. Things are not going to be the same anymore. So this is all self-contained. And then another nice thing about it is the thing that's actually signed is the image that gets mounted to your file system. You don't have to like say, okay, this thing is signed. Now I'm going to run it through this tar program, which is going to change the bits all around and flatten it out with a, you know, overlay file system, which changes the bits all around, and then, you know, create some Frankenstein thing and then mount that to my file system, which might be totally different from when the thing was actually signed. The thing that's signed is the thing that you mount. There's nothing, so that prevents what we call like a time of check to time of use, Toctau security flaw. This is actually a pretty nice solution. Yep. Good question. So the only thing that has happened remotely with the key flow, the key signing flow so far, is that I've pushed public key material up to the key store. That's right. So you could generate a key without being signed in. I don't know if we've got a check in place to not display that prompt if you're not signed in, but it obviously won't work. No, no. Just, yeah, it's this actual file that's signed. Yeah, and I'm not going to get into it, but this is a SIF file. That is a Singularity image format file. It has partitions, and there's a way. You have a SIF tool that you can use to look at the different partitions in the SIF file. This is pretty advanced stuff. I wasn't really going to talk about it, but I'll just do it real quick. You can list the different partitions in your SIF file. If I did that, I would see that I have a file system. Same thing. I've got a definition file, which is metadata, and I got that signature block. And the cool thing, another cool thing about this workflow is that you can have more than one signature block. So I can say, this is a good container, I sign it, I vouch for it. You can say that, you can add yours, somebody else can say that, and then you can put in things in place where you can say, I am only going to trust this container if it's signed by all these 3 people, or I'm only going to trust this container if it's signed by Sylabs, Canonical, and some third-party container security company, you know.
We've got 2 more questions. How did it know which key to use in signing?
It knew, that's a good question. It knew because I've only generated 1 key. I only have 1 key available. If you generate more than 1 key, it'll ask you, which key do you want to use?
And secondly, are there any advantages to building a container locally using remote, or locally over remote is what I guess?
Yeah, so if your container, once again, if it's really big, if it's going to take a long time to build, you know, that there are limits on what you can do. Once again, if you need to copy files from your host system into the container. So there are caveats and limits. By and large, I would say it's probably better to just use the remote builder. I guess another caveat or another, so you can avoid being root by using the remote builder. But the workflow that I showed you yesterday assumes that you'll build a writable container, you'll shell into it as root, and you will play with it to try to install things until you get it just right, and then you'll go back and build the final container. That workflow is not going to work if you don't have root on a system, right? So in that workflow, you could use the remote builder to build yourself a writable sandbox, but then what would you do? You know, you could shell into it as writable without root access, and then you couldn't use the package manager or do anything like that. So there still is a place for you having a VM where you've got root access. There was one other thing I was going to add, but I forgot what it was. All right. It might come back to me. If not, it's not important. Okay, so now we've got this signed, and once again, we've got this signed container, and all that is apart from the Singularity container services. So right now, if I do something like verify, this is the command that you use to actually check that the container was signed. I'm going to say, yeah, this is the fingerprint. The key that you used is local. Here's the person who signed it, and yep, you're good to go. Now, just to finish the example, I want to push this container up to the library so that it's there and it can be used. Go Singularity, push. The thing I want to push is this Alpine SIF, library, D. If you start messing with my containers at all, you're going to get a little little bit confused. There are two of me. I am Godlove D, and I'm also Godlove DC. Godlove DC is when I was at Sylabs, and Godlove D is me myself. So just so you know. And I'm going to push this to test, Alpine, just Alpine. I always get confused, and I always put SIF on the end of that. Don't do that, because then your container will be named ein.sif_latest. Okay. Now, that should be there under latest, and if you guys wanted to Singularity pull library : / Godlove D test. Get that container I just signed, and you can verify it, and you can make sure that that's the fingerprint. That's the entire workflow. And also, I'm going to show you really quick, just in case you don't do that. Just real quick. I'm going to clean all this out in a second, but not quite yet. I'm going to pull our trusty LOL cow example. You might remember that when we did that, at the very beginning, it said the container might not be trusted. Run Singularity verify to make sure that it's trusted. Find this container. I signed this container while I still worked at Sylabs. That's why the address is different. I can verify that this is the correct fingerprint. And you'll notice there's a little difference here. This is why I wanted to do this and point this out. When I checked it, I don't have this key locally. This public key material exists up on the key store. And so when I pulled it and I checked it, it had to go up to the key store and it had to grab some public material in order to verify. And you know that it did that just simply because it's got that little remote line there. And that means it just grabs some public BGP key material and it used that to verify the container. Okay, so that's the workflow for building using the remote builder, signing your container to make sure that it's that others can trust it, and then also pushing and pulling and verifying containers. Little thought experiment, maybe it might be good to talk about too. Should I have signed this container? And can everybody trust this container? So I like to ask this because a lot of times we think about security as being like, yes or no, things are secure or they aren't. And there's like lots of levels of gray in between all this. Let's go back and look at my dev file. So I just grabbed a container from the library. I didn't check to see if the container was signed or not. From my perspective, this is just some rando container, right, that I just downloaded and then I built and then I signed. So we had a lot of discussions at Sylabs about this when we were, building this whole infrastructure, and we were making default containers, and then in some instances we were signing them. And so we were like, well, we're kind of implicitly saying, trust Sylabs, trust us as an entity now. We've signed this container, so it's okay to use. What does it mean for that to be okay to use? Does it mean that we built it directly from the mirror URL from the operating system? If we start from an official or a certified container that's up on Docker Hub, does that meet our standard of approval as well? That we can say that we can sign it now and we can approve it as well? So these are things to think about. You can look at the definition file of a container when you get it and see where it came from. But ultimately you need to be aware of your containers, where they're coming from, who's building them, and all all those kinds of things. Okay. Oh, really?
Yeah, I've got a comment here from that as well.
Okay, that's weird. Well, let's go looking for it. Oh, I think I know why. All right, let's go look for it. That's great. I'm glad that you guys ran into that problem. All right. I mean, you know, I'm not glad you ran into the problem, I guess, but now, so it can be a little hard to find these containers. This is okay. This is all the stuff that's been built since I built it. This is one of the complaints I have with the library, actually. It can be kind of hard to find things sometimes. Look at that. No tags. So you can't pull this container. Nobody can pull it. Because the only way to pull a container is using the latest tag or some other tag. You can't use a blank tag. And so that's when I went through that. So the way that I should have pushed it. So we've gone back and forth. So I keep saying we because I used to work at Sylabs. The Sylabs team kind of went back and forth on that in discussions for a while. Docker just automatically says whatever you push is the latest. That can be problematic for some reasons, though, because you can accidentally swap out the container that you already have as your latest with a new one. And that can and has led to some pretty costly mistakes that I'm aware of that companies have made by having all of a sudden non-reproducible results and not knowing why. So I think that, you know, once again, Singularity's philosophy tends to be put it in the hands of users. What I should have done, I guess, is give it the tag when I push it. Didn't do that, so it just said, I don't know, you know what you're doing. I guess you don't want a tag. So now I got to go back and actually give it a tag. Do this through the GUI like so. Thanks. There we go.
Can you use the hash if there isn't a tag on it?
That's a good question. I don't know the answer to that. I assume that would probably work. Yeah, I mean, I'm like 90% sure, thinking about how it actually does the pull command, that's going to be in place of the.
Currently, yes, using the hash works.
Cool. Thank you. Right. Okay. We have a few more things. I think I'd like to cover a little bit more before we take a break. If that's okay with everybody, or are you like ready for a break now? Who wants a break now? Put your hand up. Okay, cool. Let's keep going then. Yeah, that was, I mean, it was fairly light material right there. Good question. I think I could probably just, I think I could probably just click somewhere. If I wanted to make this private. No. I actually don't know. Yeah, I'm sorry. I don't know the answer to that off the top of my head. Okay. And like I said, the cloud library is still in beta, so it could be that there are bits and bobs that are kind of hanging and missing, and it's a little clunky sometimes. All right, the next thing I want to talk about. So I want to get back to actually using the command line a little bit more, and I want to get back to talking about how containers interact with the host system. And so in order to do that, I want to talk about bind mounting. We talked very briefly a little bit. We had an example yesterday where we used a redirect, and we created some text inside the container, and we redirected that to your home directory, and I said you should be really impressed by that because it just worked, and you didn't have to do anything special for that to work. We're going to be a little bit more explicit. So I'm going to shell in Singularity shell LLCal.sys. Yeah, I've got LLCal.sys. This is the one we created yesterday. Remove in containers and the test, just because I'm worried about filling up my disk. Debian one, and yeah, okay. Error. Oh, okay. You might run into, if you try to do similar, you might have stuff that's owned by root, and so it might tell you can't remove it. You can't remove it as root. Be careful when you're doing that. Just you don't want to mess up your virtual machine by removing something that's critical. Okay. We're going to use LLCal.sys. Let me shell into it. Here are the files that I can see. So notice that my current working directory is the same when I shell into the container, and then I can still see the files. In the example here, I'm going to echo word routini, home Java text, and that's because routini is what a Java says. Actually, I didn't copy and paste right. I'm just going to touch something. No, I should stick with the script. So let me do LSL, what's in my home directory, text. Okay, maybe that's just within the container. So I popped out of the container. What's in my home directory? I've got this thing called java.text. I look at the what's inside of it. It says routini. So I just was inside the container and I created something. How does that work? Well, there are a bunch of special directories that Singularity bind mounts into the container by default on your behalf. Those include your home directory, which is what we just saw. It includes temp. That's important to know. If you are sticking stuff in temp inside the container, you're doing that on your host system. And if you delete everything out of temp in your container, you're deleting everything out of the host system temp. And then some system-specific directories like proc, sys, and dev, which are kind of needed to make the container work properly. You can bind mount other stuff if you want to, okay? And you can do so either with this option, --bind, or by using the Singularity bind path environment variable. Don't do this, okay? I've already created a data directory /data on your virtual machines to play with. And I've created some files there, and I've made them owned by you. So you don't have to do this. This code block here is already taken care of for you. So let's, oh, there's a typo. Okay, so let's hop in to the container. Actually, let's stay out of the container for a second. Either you've already got this /data directory on your virtual machine. Name that data, and I kind of set it up like this, sort of an analogy to BioWolf. So BioWolf also has a /data and then your username directory. So you can bind mount that into the container and then use stuff there. So let's shell into the container. That should not be surprising. There is no data directory inside the container because you didn't tell it to put it there. Okay. So now we're going to shell into the container again. And this time we're going to say bind. Syntax for this is data is source destination. Okay. In this particular instance, the source and the destination are identical. In that case, you can just singular. You don't have to put the source : destination pair. If I wanted to bind mount additional things, this can be a comma separated list. Say, what this would do is it would create the /data directory inside of the container. It would create another container called bar, and it would bind foo on the host system to bar inside the container. And then it would also create the directory called blah inside the container, and it would bind blah on the host system, to blah in the container. So bar will be at, oh, yes, sorry. Yeah, that would be, I don't know what it would do there. Probably it would be in my home directory or something, yeah. In this case, it will create /bar. Was that going to be your question as well? Yeah, sorry about that. We don't need to do all that. We don't even have those. So let's just bind data in. And the big ta-da is how you can see all of your data inside of your container. Yeah, and so now you can actually write to that. So that's mounted. You can also add options to that bind command to mount it as read-only if you want to, but by default it's mounted read-write. And so you can write to that directory as well if you wanted to. And just to kind of, just to drive that point home, I'm going to touch foo. Foo is now there. Foo remains. And then just to make sure that all this is crystal clear, now all my data is in mount inside the container. It's not in data anymore.
So the question was raised, how is the bind option different from using %file in the def file? Is it more flexible?
Oh, that's a good question. The two are different. The two are fundamentally different. So if you use %file in the def file, then what you're doing is you're actually copying files from the host system into the container. And those become immutable. They become part of the file system partition. That would be useful if, for instance, you had scripts that you had written, like Python scripts, that needed to be executed as part of the container execution. You might copy those in at that point. But they're not bind mounted. They're not. They have no relationship anymore with the host system once you do that. They exist in the container by themselves. They could. You could use the % files section of the definition file it also takes source destination pairs in the same way. So I could copy my, Python dot whatever, to like /op/ my program / your Python dot whatever, and then that's where it exists in the container. I'm binding directories that exist on the host system. Those could be external drives, but they could just be, yeah.
So my question was, for the purpose of, right? So if you think something like
Yeah.
this.
Yeah, it can reduce reproducibility. That's a great point. Yeah, so one thing that sometimes people do is they create a Singularity bind path environment variable and stick it in their .-rc and then forget about it. And so then you've got all this stuff that's bind mounted into every container that you run. And that's cool and it works great. And then you send that container over to a colleague and you're like, just run this. And they're like, nothing works. And they don't understand why. And it's because of what you just said, because this renders it not reproducible anymore. You're interacting with your host system in a way that might not work on another host system. So that's a good thing to keep in mind. Okay. All right, so I think that's pretty much all I want to talk about bind mounting. The next thing I'm going to talk about is the Runscript, and then those pieces all together, bind mounting and Runscript and building your container, those pieces are going to be enough to start making containers look like executables on your system. And so that's the direction in which we're going here. I think what I want to do is I want to talk about the Runscript, and then we'll take a break after that. And then I've got, after that, an extended example where we're going to go through, we're going to actually do an installation, a containerized installation, and I'm going to show you, this is pretty much exactly the way that the NIH HPC staff installs containerized applications on BioWolf. So you might not know, but there's hundreds of applications which are containerized on BioWolf, and when they run, they just run inside containers. And other than maybe a few warning messages or something, you might never know the difference. So I'm going to show you how we do that so that you can see how you could, create containerized applications too, maybe for your lab mates or something like that. Okay, let's talk about the Runscript really quick. Yeah. Let me think about that for a second. The idea would be that you've got something like, you could. So let's say you've got let's just for the sake of example, say you've got a /data directory within the container that doesn't exist in your home system and it's got some files in it. You could convert that container to a sandbox and then just copy the things that are in /data to your container. There's not any real Singularity built-in way of doing that though. I'm trying to think. I don't think that's a very normal use case. That's kind of what. So I've got the last example that we're going to do. We're going to create a directory that's called application bin. And in the bin, it's going to have a bunch of binaries that you can execute. And it's going to be kind of tricky the way that we do it. But it's going to fake an installation on your system. I've got a container that I already talked a little bit about on Singularity Hub that does that for you. It copies, actually that example, it copies a subdirectory to your home directory and then puts files from within it. It's got a payload, puts files from within it out into your home directory. So yeah, you can do that. The home directory is a particularly easy one because it's bind mounted by default when it runs. Yeah. Yeah, you could do that. Yeah, I guess that would be easier than what I was saying, converting it to a sandbox. You could just shell into it and copy things out. Okay, cool. All right, now I want to talk about the run script. Up till now, we have seen run scripts that only do one thing, right? So the run script that we showed before, it ran fortune, piped that into calsay, and then piped that into lolcat, and that was all it was ever going to do. You can make your run scripts more flexible. I've already alluded to the fact that you can actually do argument parsing, for instance, in your run script. So just like in a shell script where you've got a list of arguments, you parse them to figure out what your user wants to do with your program, and you do different things depending on what the input is. You can do that with your run scripts as well. Or you can do things like, look for presence of some file, do X if you can get the file, Y if you can't. Look for the ability to use the internet, do X if you can ping some server, Y if you can't, all kinds of things like that. So the example that I'm going to go into, let's say you've got a program, it takes a text file as input, and it does something to that text file, and it produces another text file as output. That should be, that's a pretty flexible, pretty common situation that a lot of people are in, so hopefully this is an applicable kind of thing to think about. Now in our case, because I love that lolcat example, it's going to be really silly. It's going to take a text file as input, it's going to reformat that with the lolcat ASCII art, and then it's going to produce as output another text file that's got that cow in it. That's going to be in our example, but you could use this for anything. You could use this actually for useful scientific things if you really wanted to. All right, we already have this file called data input in the /data directory, so you don't have to create that. Here's basically what I'm going to be trying to do. This is kind of like harking back to the examples from yesterday. By cat data input, if I just cat it, it gives me that phrase. Cow, I pipe that into my lolcat sif. Pipe that into my calsay program within my lolcat sif. All right, guys, here we go. I'll get it right. And then I don't want that to just echo out to my terminal. I actually want to create data output. What this is going to do? It should produce an error. Oops. No, it did not produce an error. Did it produce an error? Yeah, so I guess I was wrong previously when I said that example worked because your home directory was mounted. So I guess we're actually, by the time you get to standard out, it doesn't matter. It's already, it's just echoing to your terminal, and so you can redirect to things that just exist on your host. Sorry about that. That will still work. Later on, that's going to error out. Okay, so that's what I'm trying to do, but it works, but it's ugly. What I'd like to do is I would like to say, I would just like to use my Singularity container as an executable, and I would like to give it like an input and an output. So let's change the definition file to make that happen. Right now, you'll remember, if we just run, this is what happens when we run it. So let's change that. The Runscript right now just does this really silly thing that doesn't help us. I'm going to rewrite the Runscript. I'm going to say if number of arguments not equal to 2, then going to echo a warning or an error to the user. I'm going to exit. Okay, does that make sense? I'm basically saying, you need to give me 2 arguments. If you don't give me 2 arguments, this script is going to say, give me 2 arguments, and it's going to exit. This is really kind of dumb error checking. You could be a lot smarter with your error checking here, but this isn't a bash scripting course, so I'm not going to get too complicated here. I'm going to keep it really, really simple. This is like super basic argument parsing. Then, oops, if we actually get that far, if we get below this if statement, then we've got 2 arguments. So if we actually get that far, I'm going to say, display the output of the first argument. So the first argument is going to be that input file. So cat that output, type that into calc. Redirect the output from calc into our second argument. Once we put all the pieces together, this script is saying I need 2 arguments, an input file and an output file, okay, in order to run. Give me those, and I guess implicitly if they're text files and all that kind of stuff, because this thing will bark. Give me those, and I will create for you this cow ASCII art. I'll reformat your text. Check that this is all correct before I move on. Okay, let's rebuild the container. Yes, since I'm logged in, I might as well use the remote builder. I think it can take more than 1 argument. So really, this whole script I would probably do different. Let me, as soon as this is done building, we'll look at the script again. Instead of using just like $1, $2, and things like that, I would probably use $at, which is the entire command line. And then you can take that and you can parse that piece by piece. I'll show you something. If you scroll down, if you skip ahead, if you scroll down to the bottom of this, I can do it for you. Scroll down to the bottom of this example. I got kind of a thought question to pose to everybody. I guess I could pose it now. This $at, this quoted $at, basically means the entire command line. So a lot of times you'll see Runscripts that just look like this, or maybe it'll, I don't know, Ruby or R or something like that. So I don't want to give away, you know, what does everybody think that does? Maybe we should talk more about Runscripts before we, but you can think about that, and you can think about how in a bash script normally do you parse the command line, you know, and these are the things you do. You might just take the entire command line and feed that to calc. You want your program to work like that. Or you might, you know, parse the command line yourself and feed bits and pieces of it to calc or bits and pieces of it to LLCat or something else. Okay, so I've built this new container. Before, when I ran it, it just echoed something. It was pointless. Now when I run it, it says, you silly, silly person. Okay, so I need to give it 2. So we all have a file called /data/bader.txt. That's what's going to be reformatted. That's what's going to be analyzed here with our very scientific calc analysis program. And then it's going to produce for us this output file /data_out1. This, I'm pretty sure, is going to error. Yeah, that was the error I was looking for earlier. Why is that erroring? What the heck? It's erroring because it's not by-mounting that data directory. Okay, so this would be a good example, or this would be a good time. Use that variable. Now, once we set that, every time we use Singularity, we should be good to go. I'm having trouble with my Runscript. Oh, I messed around with this definition file, didn't I? Yeah, I sure did. Yesterday I said, I hope I don't need this definition file for anything in the future. Sure did, didn't I? Okay. Now I'm assuming that none of the other examples take LLCat or Fortune. I think we're gonna, in the next example, we're gonna blow everything in this directory away and start. Okay, so now this should work. I have a file called out1. Data out1, we're going to find out what Bader says. He says, I am your father. Does that make sense? So now is the time where a lot of times people start to say, okay, you're starting to lose me. I used to teach all this in like a 3-hour, just 1 3-hour class, and maybe that's why people are getting lost at this point, but it's cool to ask questions now if you do. Oh, is that screen not on? Let me pull the def file up, and then I'll try to figure out how to start the screen. That, ooh. I mean, if that does anything. Yeah, all right. I was just pressing buttons. I didn't know they were actually doing stuff. Now also might be a good time to think about. Yep. Oh, sure. So I changed the bootstrap to Docker here in this file. That's just pulling this from Docker, but you could also, okay, let's talk about that a little bit. Yesterday we talked about the definition file and we went into some detail about it, and we use primarily for the bootstrap method bootstrap or deb bootstrap. And I talked about how that was using a program on the system that is built specifically to create a Debian type operating system. So how would you know all this stuff? If you go to the documentation, this is kind of hidden. It's in the appendix. If you go to the build modules under the appendix, it will give you all of the supported build modules. Remember when I said, we used to call these bootstrap agents, but then we started calling them build modules. But in any case, it's the same idea. Remember I said that depending on what bootstrap agent you use, you're going to get different keywords. So in the case of the library, for instance, you get the keyword bootstrap. Oh, I'm sorry, that is the main keyword. You get the keyword from, and that's pretty much it. With Docker, you have from, you also have registry and namespace and include commands you can use and so on and so forth. So your question was about what was the significance of changing that to library? Yeah, so I mean, anybody can use a library. So you could start from, in practice, most people start either from the container library or they start from Docker Hub and they do their builds. Okay. Oh, yeah, I'm sorry. I should maybe, when I do this in the future, maybe I should have like another mic, like a real mic. Okay, any more questions? Okay, I guess the only other thing, so I wanted to kind of think about this simple Runscript and think about what this does. And I also want us to be able to take a break. And then in the last hour or so, we're going to talk about faking and installation and then field whatever questions, other topics I didn't get to that you guys are interested in, we can talk about. So I guess over the break, let's contemplate this, and then you can ask me about it, or we'll talk about it again when we come back. So I guess 10 minutes, 15 minutes, something like that.
Let me see if I don't know about this.
Yeah. Yeah. Yeah, so I didn't get a whole lot into it, but Docker containers feel very different. So you might have noticed there's differences when we built from Docker. There was multiple different status bars that came up. And what was happening is it was now loading pieces of that. It was now loading multiple tar archives. And so, and that's what a Docker container is. It's a bunch of layers.
Sure. Start from the real Docker container.
It does, but what it creates is a zip file. And when it does that, it actually mixes information because it takes all these different tarballs and compresses them into a single zip file. And so you can't move one direction. You could. Now, here's the funny thing. That actually creates a Docker container from Singularity. I'm going to go through some backwards to this. But what you'll end up with is just a single layer.
And it won't be the same in the sense that, like, one of the things about it, talk about this yesterday, it's like reproducible data because multiple different things all show the same way. People would be able to do that with the new you go because it would be one layer, and that would be it. So you would have to export the container in what's called the ACI format, which is the you'd have to kind of dig through some guts in order to be careful to figure out. This is about the proof. Why do you like to do you kind of don't, but anything of consequence that you would want to do while you build it, you would need to do. So I give you kind of an example. I showed you yesterday, you don't have to do like the Singularity build, Docker // right? You do that, what's going to happen is it's going to go to Docker Hub, download the layers, build the zip file for you. That's it. You don't actually have to do what you do. So the Singularity checks to see, if you give it a definition file, checks to see if it just reproduces. The reason for that is, let's say you want a definition file. Once you got that container, pretty much everything inside of it is going to be right? Or should be. The file system operates properly. So then, when you do something, you can install some file somewhere. Use the file structure. You just want to copy a file somewhere. Couldn't do that because everything needs to be. Just one. I wanted to make container but then I just want someone else to put on actually you can just put it on the system and then where are you going to put it? I can put it in your home directory is fine now to do it. So you're saying that is yeah, I mean all the places where you normally like your home directory or you use temp. And those are very bind out from the system into the container. So even if you created another user and installed something in your home directory, the user who used that container ultimately would not be able to use that because they wouldn't be able to do that as a user. Even if you figured out how to create it as a user in the host system, you put it in your home directory. The actual user's home directory bind down the top of the container. So it's going to make it invisible. So for a while we had this, it's a good conversation to have. We had this conversation actually internally in Sylabs amongst the developers. Why do we have this check that you have to be rooted when you build from a definition file? Shouldn't people be able to build containers from a definition file? And we found in practice, there's very, very, very little that you can do inside of a definition file from that root. And the problem is it's confusing users. So everything starts to fail, and they don't understand why it's failing. And it's because I can't really do anything. So we just love that place. Yeah, there was something else. So you get basically we have the same permission get their own and then have permission. I don't know much about it. those individuals, we say, the different user, don't see and then with honors, a user, but I will get you can sounds, yeah, line up, like,
Oh, yeah. Yeah, you can't. So the reason that you can't is because two things. And once again, this is just Linux kernel stuff. So when you mount the file system, you mount it with a specific option that says that you can't run SetUID programs. So, let's say you run the program ping. Ping does some privileged operations. Specifically, it opens up a wrong socket. And that's, you can't do that as a normal user. But you can do it with ping. Ping is written in such a way that it's only going to operate, it's only going to open up this wrong socket. It's one particular operation. It's safe for you. So on older systems, newer systems, it uses something called capabilities. On older systems, it uses what's called SUID. What that means is the ping binary is owned by root, and it has a bit set on it, a permissions bit set on it, so that when you run it, it will run it on your behalf. And so unbeknownst to you, maybe, when you run ping, you're running with the permissions as root. That's okay because it just does this one particular thing. Now, SUID bit programs have to be written very, very carefully. As you can imagine, if somebody made a mistake in ping, then it could be an escalation route. Somebody could use that to escalate the privileges from root. And that's the kind of, so SUID programs are like often some of the first ones that people, like hackers will try to see something like that. It can be dangerous. What to do, you could write an SUID program with a container. I've done this. You could write one that will basically be sudo. It will take whatever command line you give it. It will execute that command line. Obviously, that would be very, very dangerous to contain. So what you could do is you could copy that same program. Using that program, you can make a copy itself out to the host system and whatever the host system. So there's an option when you when you mount a file system, there's an option that you can pass it so SUID that programs won't work. And that's how Singularity finds the file system is without that in place, that you can't access SUID programs. That's one safeguard that's to put in place. And that means that even if you install sudo inside the container, it's not going to work. The sudo is an SUID even program. The other thing that it does is it sets kernel flag called PR_new_priv, which will prevent any processes from escalating their privileges. So when you enter the container, that's set, that kernel flag is set, and so you can't processes escalate their privileges. It's pretty long.
When you started, there was another question about if there was any special procedure you need to do if you're using.
Yeah, okay.
We've had a couple of those. So
Yeah. There's a miscellaneous section in the everything. It's not like it's just the instructions. Exercise. So maybe I'll pop that up.
Great.
I'm on one more time.
Well,
Yeah. Yeah, I need that. Oh, I saw that. Yeah. I was about to. Right. My first hand. So there's some stories. I never used it. You have one of that.
Are we missing anybody? Is this everybody again? Okay. Jean says we're missing somebody. She's using sign language. Oop. All right, I think we got everybody back. About 15 minutes. So, all right. I wonder if everybody's been contemplating what this little two-liner run script does. I'm sorry, I can't hear you. What you would do here is you would execute the container. So you could name your container Python, and then when you did, something like Python arguments, it would take all those arguments and it would pass them to Python inside the container. Or yeah, you could name the container. Yeah, you can name it that. So the point is, yeah, so you could name your container any of these things. You could just name it Python. That would be really confusing if you didn't put that container on your path. Because then when you ran Python, you'd pop into an interactive prompt. It would be inside your container. You would only have access to whatever files you'd bind onto into your container. But yeah, it's like, you could pass it scripts. You could do whatever you wanted. This would be a nice way to have like some one-off different version of Python running on your system. You'd have to be careful with it. Does that make sense based on that little run script? So basically, if I name this container Python, let's just say I named it Python. I didn't give it any arguments. When we went to this script, so it would when I ran the container, it would say, what's my run script? It would say, this is my run script. I should run Python. And this would be blank. The arguments would be blank. So it would just say, run Python. And then you'd pop into an interactive shell inside the container. If you passed it a script, it would say, okay, there's a script, assuming that it can see it inside the container because it's in your current working directory or in a within the Python inside the container. Yeah, right. You'd have to have it installed. So this is a pretty simple, and you actually see these kinds of run scripts quite a lot. You know, just some interpreter with all the command line. Okay. So now we've got our brains working a little bit. Let's go to the last chapter that I want to cover, called Faking a Native App Singularity. So we've moved in the direction of pretending that our Singularity containers are executables and allowing them to, you know, have some arguments, do some argument parsing, do some stuff inside the container. We're kind of going in that direction, but we've just used the Runscript to do that, which is, you know, it can be as complicated or as simple as you want to write your Runscript. And that's really great too, because it's a portable thing to do. You know, your Runscript moves around with your container, so you can make that do all kinds of stuff. I'm going to show you now a little trick that we use to be extremely flexible and to really, really make it look like apps which are inside of the container are actually just sitting on the host system, even though they run inside the container with all the dependencies, their own glibc and all that stuff. And I alluded to this before, so we've got right now about 100 apps that have been installed by staff members that are containerized. And these applications are just things that are either difficult to install, they have package, they're meant to be installed using the package manager maybe, they have lots and lots of dependencies of specific versions of things, or frankly, sometimes, you know, staff members are a little leery about, you know, what is this application trying to do on the system? Let me just containerize it instead. That'll make it a little safer. So we've got about 100 apps that are containerized, and this is pretty much the method that staff use to containerize the apps. The great thing about this is then the application bin directory that we're going to set up here is added to your path using the module files that we build. And once you add that thing to your path using module files, you've got those bins on your path, and you use the application. You may not even know or care that it's containerized. You could do this. I think that you had a question yesterday about creating software, containerizing it, and then distributing it to folks in your group so that they can run it. If you use this method, for instance, they would have to really learn minimally about Linux containers in order to be able to run their applications. Okay. Okay, so the first thing we're going to do to start off this is we're going to blow everything away in the LOL-cal directory. If there's any other portions or anything you want to ask from LOL-cal. So if it's not a shared system, if it's a system that they're just going to use independently, yeah, they would still have to install Singularity for this to work. Okay, so let's make sure that we are in our home LOL-cal directory. Everything away here in a second. We want to make sure we're in the right directory. Okay. Dangerous command to run if you don't know where you're at. Okay, we're on a virtual machine, so it shouldn't be a problem. This might give us an error, I'm not sure. Oh yeah. That means it's even more dangerous. Be very careful. This is the kind of command that can mess your system up, so. We didn't. Just out of curiosity, everybody understands that like that's like a virtual machine? Okay. Just remove the directory? Yeah, I could do that. We still would have had to have done that, because it contains things that are owned by root. But no, we still would have had to do it. But you're right. I mean, it probably would have been a little safer than just giving star. Okay. So what I'm going to do, I'm going to set this up, and this is just, you can do this any way you want, but this is kind of the way the staff sets it up, and I think it's a pretty good method. So I'm going to set up two different directories. One of them is called bin, and one of them is called libexec. Those are, they're going to be faking those types of directories that you would normally have for an application. We're not actually really going to have libraries and really going to have bins. What we're going to have is Singularity container, which is going to pretend to be a library, and a bunch of symlinks, which are going to be bins. But you'll see how it all works here in a minute. So let's make these directories. Okay. Got these two directories now. Okay, I'm going to go ahead once again and pull the lolcal container, and I'm going to stick it in that libexec. So that's going to be my set of libraries, is this container. That happened really fast, and that's because it's cached already. So it just basically copied it from one place in the file system to another. Okay, now, my copy and paste doesn't seem to be working. I hope that this works, because this is kind of long. Hopefully your copy and paste doesn't work, then we're going to have a few seconds while I do this. There we go. So what I'm going to do is I'm going to create, with this cat command, a file in libexec called lolcal.sh, and I'm basically going to create it until it sees this string EOF, and it sees this string EOF, it's going to stop. We'll do that first, and now let's actually look at it. There it is, it's this lolcal.sh. Before I forget to do it, I'm going to change permissions on it so that it's executable. Now it's executable, and now let's look at it. This is going to take a little while to look at and figure out what this is doing. Okay, this is a little bit more, it's not super advanced bash scripting, but it's more advanced than what we did previously. I'm gonna kind of step through it a little bit and talk about what it does. Okay, so we've got the shebang, bang bin bash. This says use the interpreter bash in order for all these commands. I'm going to export time path, and in this case, that's going to be /data. So every time I run this script, the only thing that's going to get bind mounted is /data. Okay. On the system at the NIH HPC, there's actually a whole slew of bind paths that we have in order to enable whatever data directory the user happens to have and wherever that happens to be. And you can read more about that on the Singularity application page and how we do that. Okay, now I'm going to set this environment variable called dir for directory, and I'm going to use this bash source 0. That's going to give me the command line. It's going to give me actually the location, and then I'm going to use readlink-f. This is going to get rid of any symlinks, and then I'm going to ask for the dir name. So what this is going to do, this bash source 0 is going to be where the shell script is. It's going to be the full path to this shell script, lolcal.sh. And then it's going to make sure that there's no symlinks there, so it actually gets the actual directory where this shell script lives. And then it's going to use dir name to say, don't use the ending lolcal.sh. And basically it's asking, where am I? Where am I running from? This is where I'm running from. That's what dir is. The image in this case is locale.so. That should make sense. That's the image that we just downloaded. We named it that specifically. The command, this is another, so dir name and base name are both, they're either programs or they're bash built-ins. They might be bash built-ins. But this, like $, and then start and end parentheses, says execute a command, and whatever the text is from that command, use that as, in this case, what we're setting the variable to. So that's how dir works, and that's how command works too. So $0 is going to give me, so this gets kind of tricky. It's going to give me the entire command line, and it's going to give me, it's like the opposite of dir. It's not going to give me the directory where this command was executed. It's going to give me the command itself. Now, watch that, because we're going to start symlinking. This is the magic. This is the little trick that makes this all work. We're going to start symlinking stuff to this script. And so the things that we symlink are going to end up being the commands. So if we symlink like ls, then when it gets to this line, it's going to say, oh, the command is ls. And that's how all this magic is going to work. And then the argument, I've already said, $@ that's just the command line. So this is all the arguments that the user provides. We're just going to pass those right on through into the container. So I've got this echo here just for like debugging, just so you see what's actually being run. But the final command that gets run is a Singularity exec command. It's going to say, where am I? Where's the image? So it's going to assume that the shell script and the image are in the same directory. And that's going to be the case because we're setting it up to be the case. And then it's going to say, what command did you invoke? That's the tricky one, because that's going to end up being whatever symlink is symlinked to this script, which is, that's kind of, it's hard to understand until you see it, but it's pretty groovy. And then, whatever command line the user provides just goes right through. See how this works. Once you've got this set up here, you can start creating symlinks. I'm going to create them in bin just to keep things nicely organized. So I'm saying go up a level and look at libexec because this is going to be in bin. So from its perspective, link something called fortune to that. I want to link something called cap to that. These are the links that I just created in bin. They're all pointing to that wrapper script, that magic wrapper script. And so when I call cowsay, that's what's going to end up being that CMD variable within that wrapper script. And fortune and cat and so on and so forth. Let's just test that out and see how that works. Kind of drive the point home. This is what the entire directory looks like. This is what the structure of it is. I am going to just cd home. Now, on the system, on the Biowolf system, you would load a module to get one of these bin directories added to your path. I don't have modules here, so instead I'm going to export path equals that's going to add that directory to my path, as long as I put that in there correctly. Thank you. It should be that.
Yeah,
Did I screw up?
which lolcat?
Ew. Right, LOLCal is confusingly the name of the directory in the image, and LOLCat is the name of the. It might, depending on what you're trying to do. That's a good question. So the way that I've done it here is I've prepended a path to the path variable. The way evidently I did it there is I appended the path to the path variable. If you prepend it, if you prepend it like I just did, if I had calsay installed in a system directory and then also installed here, I would overwrite its location if I prepend. If I append, then the system version of calsay or whatever it is will remain intact and will overwrite mine. That gets important if you're like, you've got binaries and things that are named the same. But in this case, we don't, so it shouldn't be a big deal. Okay, and so now I should be able to do things like a move. Ooh. So this is that echo line that's in my shell script. Once again, that line is created based on all those variables I create. It figures out where it's running, and it plugs that into the dir, the dir variable. That's the contents of the dir variable. It figures out the name of the image and plugs that. Well, it doesn't figure it out. I supplied the name of the image. That's the img variable. I'm going to skip that for a second. It figures out the command line. In this case, I've provided the command line moo. And it figures out its own name. And its own name changes depending on which symlink I use to invoke it. And in this case, its own name was calsay. Oh, no. So just to kind of, say it another way, this bin directory is on my path. When I run calsay, it says, oh, I'm symlinked olcal.sh. Run that. It starts running that. It says, go ahead and bind that data directory in case I need any of that data. Your name, where am I? Without symlinks. This is the name of the image. What command did I use to run it? And that's going to be, in this case, I'll say, I'm sorry. That's the entire command line, and then go ahead and do it. All right, so now that we know how it works, I'm going to remove this debugging line. And that's on my path, so I should be able to do like calsay, the whole thing, fortune. Boom, it just works. Every single one of those commands, it enters the container, executes the command, and then pops back out of the container. Since I've in the container, pops back out, pops in, out, and then since I've bind mounted the data directory, well, okay, probably still have this set. Yeah, I do. So I don't have that set anymore, but the data directory is being set in my shell script. So if I do like cat, this would work anyway, I guess. Not that. Correct. Okay. That would probably work anyway. But if I had, I'm trying to think. I don't think any of these programs take files as input. But you can do things like Oilcat has help. Yeah, anything now that you can pass, anything, I'm going to say this and there's going to be some corner case that isn't going to work. I think that anything you can pass to these programs, which are inside the Singularity container through the shell script, should just run. Yeah, good questions. The question is, how do you mount multiple things inside of the script? Back there. The way that you would do that is right here, this accepts a comma-separated list. Or you could also hard code stuff into find command there if you wanted to. It would do the same thing. Okay. Great, so we've got about 20 minutes left. I have one question that has come through remotely about using X inside of a container and displaying graphics from within a container. So I can talk about that a little bit. Trying to think. I don't think I can do a demo because I don't think I've got an X. Yeah, I don't think I could easily do a demo because I don't have any X client installed on this system, but I can talk about it at least. Let me go ahead and do that, and then after that, if we have any more questions, any other topics I didn't cover, we can, we can have just kind of a free-for-all. So I have in this GitHub repo that we've been following through, I've got some miscellaneous stuff, things that people often ask about and I don't really cover in depth in this class. One of those is X11. X11 works, as long as you've got an X client, it works pretty seamlessly. So as long as you install Xorg, which is the collection of packages that makes the X graphics transfer work, then you can do, pretty much anything that you could normally do with X, which is like 90% of the graphics that you need to use. If you need more advanced things, you might have to install other things inside of your container, like OpenGL, things like that. You can make those work to varying degrees. I actually had a container for a while that I used for server-side graphics benchmarking. So you can put inside of your container things like OpenGL and then things like 3D games where you can, use the, you guys know what I'm talking about, like first-person type games and things. And then they'll actually work and run inside your container. You might have to pass the --NV option if you've got an Nvidia graphics card to make sure that the Nvidia drivers are mapped properly into your container. Recently, Singularity unveiled support for AMD graphics cards too. I think that option is --ROCM, ROCM. I have not used that at all. I don't know if that is meant to support graphics or if that's just for computing. But in any case, that's the that's the direction in which you would go if you needed to do something kind of crazy and esoteric like that. Online, does that answer the question about X. If not, I guess just go ahead and say something in the chat. Cool. So there's got to be other stuff that I didn't talk about that you guys are interested in, or maybe there are things that are still confusing or hazy that you want to talk some more about. Yeah.
I think there was a question.
Okay. So I'd have to, let me look at the help and see what the flags are. Okay. Spread. Let's do animate and see if that works. I think I can just, hold on for a second. Let me think about this for a second. All right, I'm going to cat out the definition file just to have something to, I'm going to cat out that. I'm going to put that into LOLcat. Use the psychedelic option. -A. See what that does. Does that answer your question? Is that?
From here, what about like the other method?
Good question. Let's go back and look at some of the so you obviously couldn't do that if you use the Runscript that I wrote previously, because that Runscript takes an input output and just uses calset. You're completely sunk if you're trying to do it there. If you were going to do it with exec from within this, so I just kind of gave you that example. Let me cd into the libexec directory. A little bit easier. And then what I'll do is I'll cat out. I'm actually going to do Singularity. Is this kind of what you're looking for? Singularity exec, LOLcat, and that should just work the same way. I got to get. So Singularity exec just passes the entire command line, including, in this case, LOLcat program, directly into Singularity.
Everything just worked for CUDA?
Yep.
You just need that on Linux NV.
And no, both options. So you say CUDA, and this is, so I think that the user asked about CUDA, right?
Yeah, I think so.
Okay, we should get into that. Nvidia makes this very confusing, and it's irritating. They package the Nvidia drivers and CUDA together all as one thing that you install all at the same time. And you can install them all at the same time using, they've got a self-extracting binary called it's a run.sh file. And it has everything in it. And by default, you just install it all. There are options you can give it to just install the drivers or just install CUDA. Okay, CUDA and the drivers are two different things. Even though they're packaged together, they're two different things. CUDA is a little bit independent of what driver it's running on. When I say that, I mean that the driver is backward compatible such that a newer driver will support an older version of CUDA. That's not necessarily the case the opposite direction, but newer drivers are supposed to support older versions of CUDA. The --NV option doesn't have anything to do with CUDA. It just has to do with NVIDIA drivers. And the NVIDIA drivers, when I talk about that, what I'm saying is the NVIDIA libraries that are supposed to drive the kernel module. So I don't really know how to do it in such a way that people can see online. I'm looking around for a marker right now, but that's not going to be very helpful. There's three things that we're talking about here. We're talking about a kernel module, and that is going to be just in the Singularity container by default because the container uses the same kernel as the underlying host system. And then we're talking about a collection of libraries that drive that kernel module, and they are bound very, very tightly to the kernel module. They have to be exactly the same minor version or else they're not going to work. And then we're talking about CUDA. And CUDA is a little wishy-washy. It can be a little different, and chances are it's probably going to work. And it's probably more tightly tied to the application itself than it is to whatever driver is running on the system. So when you pass --NV, it maps the libraries in from the host system into the container that need to drive the kernel module because those are very important to be hand in glove and one with the other. But it doesn't touch CUDA. CUDA is expected to be installed inside of your container because it's going to be, your application is going to be dependent on what version of CUDA you use. And that's all very confusing, and that's all, it gets very, muddy. And NVIDIA doesn't help that because they just package everything up together and just try to make it easy for you, but they're really distinct things.
And if I remember correctly, just to expand on that, there is something funny that is done the actual NVIDIA SMI binary. It gets bound in.
Yes. So not only libraries that drive the modules, but I might be able to actually define it. There's a binary, as you just said, that actually gets bi-mounted in. This is going to get kind of advanced. Hold on for a second. CD. Let's see. I think it's user local etc. Hold on. Yeah, that's NGC that we talked about a few times. Okay, so what I'm doing right now is I'm digging around in the configuration directory for Singularity. That's going to be installed in a different place depending on how you do the installation. The way we did it, it's going to be installed in user local etc, Singularity, and then you've got several configuration files. One of those config files is called nvliblist, and this determines by default what gets bi-mounted on your behalf into your container when you pass the --NV option. Basically, Singularity looks for all this stuff on your host system, and if it finds it, it bi-mounts it into a kind of special place near its metadata, and then it makes all that available libraries. Now you'll see that there's actually, it's not just libraries, there's some binaries. So this is what you were just alluding to. Typically, you wouldn't do this. You wouldn't want to bind like rando binaries into your container because your binaries have been compiled against something. They've been compiled against a specific glibc. And that glibc is likely to be incompatible with the glibc which exists inside your container. So, if you want to use a binary inside your container, usually you have to compile it inside of your container. Well, it turns out NVIDIA is a special little snowflake, and they've decided to always compile these on really old, ancient kernels with old ancient libraries and try to make them compatible with as many different glibc libraries as possible. And then these binaries, they actually distribute precompiled just as binaries. So they've already made the assumption that these are going to work under lots of different circumstances with lots of different environments. So it's actually pretty safe, even though normally you wouldn't do this, it's pretty safe to just bind these binaries too into the container at runtime. So just to finish that thought, even if you don't have NVIDIA SMI inside your container, let's just take a plain Jane Ubuntu container, take it to a host that's got a GPU in it, run Singularity --NV exec NVIDIA SMI, and it's going to pop up and show you the information about the GPU on your system, even though that doesn't exist because it was bi-mounted into your container, and that's just going to work. Okay.
Okay, so what is the best way to containerize an experiment that uses large amounts, gigabytes of data?
So the normal approach is that you containerize the analysis, and then you bind mount directories that have the data into the container at runtime, and you do the analysis there. If the data are never going to change, and you have a different use case, maybe you want to make your container available to people who want to, see what kinds of data you had and what kinds of analysis you carried out after you've published some results. There's no reason that you can't just, copy that data into the container. Your container is going to be really big. A lot of people have really strong, surprisingly strong feelings about big containers. They get really upset about them. But there's no reason. Your container can be tens of gigabytes, hundreds of gigabytes if you really want it to be. Yeah, there's different containers for different applications, and you could do that if you wanted to.
Okay, so what about compatibilities with the Singularity version? Will containers made with older versions work with new Singularity?
So the stance that Sylabs takes on that is that if that doesn't work, it's a bug. So if you create a container today and a newer version of Singularity, 5 years from now is unable to run that container that was created today, then that's a bug. So that backward compatibility is supposed to be maintained. Now Singularity cannot do the opposite. So if you create a container with Singularity 3.5 and then you try to run it with 2.7, it's not going to work because the entire idea of a SIF, a singular image format file, had not even been thought of when it had been thought of, but it hadn't been created when 2.7 was created. And so 2.7 doesn't understand SIFs, and it's never going to. But yeah, backward compatibility is a promise. If it's not made, then it's a bug. But forward compatibility, for obvious reasons, can't be promised.
And there was a question sent to you directly. I didn't get the full content.
Okie dokie, let's look at it. Okay, it looks like from Mario. Oh.
Yeah, that was the one.
How does all this work in the context of heterogeneous clusters where the login node may not have an NVIDIA card or an NVIDIA card of a different type? I guess you have to adapt your Singularity container to the GPU nodes. So no, actually this is the entire reason why the --NV flag was invented, is to maintain portability. So, okay, you've got a login node that doesn't have a GPU. You pass the --NV flag when you run the container, and the container just says, I can't find any libraries, and it continues. It gives you a warning and continues. No big deal. As long as, let's say you've got an old version of TensorFlow in your container, which will run either on CPUs or GPUs. You pass the --NV option, it doesn't have a GPU, whatever, it defaults to CPU, you're still good. You move that over to a V100, okay? It's got a particular piece of hardware in it with a particular set of drivers. Pass the --NV option, it maps those correct drivers into the container for the hardware, and it runs it. You move that over to an old, what is it, what's the old stuff?
K20.
K20, right. Move that over to a K20 that's got some old hardware in it. Coincidentally, it should still have the same drivers, but let's say for the sake of argument that it doesn't, it's got some older version of the driver. That's fine. You pass the --NV option. It maps those old drivers in. They use the hardware. Everything still works for you. That's why the --NV option was created, because the older version, the older way you did this is you actually installed the drivers into the container. And that made your container non-portable, because it would only work with one particular kernel module, and then as soon as your admin came along and updated the drivers on the system, your container broke. Oh, looks like Mario also asked about Nvidia Docker.
No, just commented that they were available. Oh, he did.
Right. I don't really have any experience with Nvidia Docker outside of just kind of like knowing the history of it a little bit and sort of knowing some of the folks who are developing it. Basically, the basic story is that it's hard to make Docker work with GPUs and other underlying hardware. So hard, in fact, that NVIDIA felt the need to step in, fork Docker, and make a different project that would actually work okay with GPUs. And that's the genesis, essentially, of NVIDIA Docker. I don't know if they have since tried to, merge those branches again, and if it's still a fork, or if it's still, maybe it's maintained now by NVIDIA upstream. But that's basically the idea behind it, is that, if you want to run Docker with GPUs, you don't just run Docker, you run NVIDIA Docker, which is what used to be a fork that would allow you to do that a little bit more easily. And other than that, I don't know too many details about, how you do that or what you do. I think it's similar to the Singularity approach.
That's everything we've got from away.
Oop, and it's noon. All right, well, the class is pretty much done. If anybody else has any more questions to ask me afterwards, feel free to stick around. But that's pretty much it. So thank you very much for your participation. Thanks for coming out both days. And thanks for listening. Good, hope so. Okay, I'm going to stop sharing, I think. Okay.